guys. I'm going to talk about the amazing world of protein synthesis. So, basically, protein synthesis is turning what your data has in your DNA into specific proteins via the 20 amino acids. So, basically, I got two cords here. Is the mix of DNA. And then the black cord here would be your mRNA. So first I'll give you a background on what DNA is. So DNA is basically just a number of different bases and mixes that go in together. So adenine, thymine, guanine, and thymine, which we'll call them A, T, C, and G, all go together in a row with like a set ladder and rungs. So A binds to T, and T binds to U every time. C binds to G, G binds to C every time. That's the way it works. So it makes it really easy to follow through. So basically, I'm going to talk to you about what happens when you need to take the information from the DNA and transfer it and make it into a protein so that we can work. So basically what happens is you take the DNA here and you kind of just separate it. So separate it, and then it's just got the one base set of pairs. So the mRNA here comes along and this is called transcription. So the mRNA comes along and kind of binds with the DNA, and then it matches the exact same as what the other strand of the DNA would. So but instead of T, A binds to U, which is urinine, and then the rest all continue. So U binds to A and A binds to U, and that's the one difference between RNA and DNA. So basically, we'll have just a run of things here where it will create kind of like the message. That's what mRNA stands for. It's messenger RNA, and it will create a message that in turn will make a protein. So after transcription happens, which is where it all binds together and it all matches up, the DNA will close right back up, so the two strands go back together, and the mRNA will go out of where the DNA is held, called the nucleus, and it'll come out through little holes like what I have is this net. So the net, it'll come out through little holes, and then in the cytoplasm, there's tons of amino acids and other things that help your cell move and live, and it helps your cell work the way that it should. So out in the cytoplasm here, the ping pong paddle here is a ribosome. So it's going to basically read the mRNA, and the mRNA attaches to the ribosome from the bottom, and then kind of like a zipper, it takes it and just kind of reads the mRNA via the clamping, like it clamps down and kind of reads it like a zipper. So once that happens, then translation can happen. So translation's really the most important part I find. So translation is basically like reading 3 sets of the DNA and attaching an amino acid that agrees with those 3 sets of DNA. So after the mRNA is attached to the ribosome here, then the shot glasses are like a tRNA. So the transfer RNA are just around the cytoplasm, and they go and they pick up an amino acid. So basically, the amino acid, or the tRNA, has the amino acid. Say it's the liquor that's inside, and you want to drop it off into your body. You're what's building the protein, and this is what's transporting it. So basically, whatever you have inside, rum, vodka, whatever else, you'll read it to go with what would be like a specific mix. So there are codons and anticodons. So the codon would be like a mix, so like Coke, 7-Up, Sprite, something. So, and then the anticodon would be the shot, like whiskey, vodka, gin, etc. So, basically, when you want to put the proper mix with the proper vodka, or the proper liquor, or else it's not going to taste very good. So, say you have a codon on your mRNA that reads out for Coke. So you want to match the tRNA or the amino acid that would be for rum. So basically, you would attach the amino acid. So it'd be like taking a shot. So you'd say, okay, I got my rum, or I got my Coke, and I got my rum. So first, you would take the Coke, and then you would shoot the rum. So the rum going into your system is like an amino acid starting a chain. So after this, so this one will be done, we'll move it over, and then the next one will be vodka. So the next codon on your mRNA would be, say, water. So you would have your water, the vodka goes with it, you take your water, take your vodka, and there's another amino acid dropping off in order to build a protein. So this happens, there's a specific start and a specific stop codon. So say the start codon was Coke and rum. The stop codon would be what you would want your last drink to be of the night. So say you follow the rule, liquor before beer, you're in the clear, beer before liquor, never sicker. So our last stop codon is going to be a beer. So a beer might read out UAG. So the beer would come over and beer would stop it, and at beer, that would be the protein. So after all those amino acids are taken and folded into a protein, it's sent off to where it's supposed to go. So the most interesting part of all of this is mutation. So there's two types of mutations. One is a point mutation. So basically, all these codons are based on kind of a specific way that you're going to build a protein. So say that this mRNA somehow got hit with something like UV or radiation, any of those things that you know can kind of make a mutation. So instead of it reading C and G, the C would change to a T, or to a U, sorry, and it would basically make the protein, it would change what amino acid it would read for. So instead of making the protein that you wanted to make, you might make a protein that kind of turns in, that can work, but it's not going to work as well, or it's not going to work at all. So that's where the mutation happens. And then there's also a complete shift mutation. So this is like an addition or deletion of one of the base pairs. So we bind the C with the G with the C, the A with the U, and the U with the A. So say that you get hit with UV and somehow one of the A's disappears. So everything just kind of moves over in the chain. So when everything moves over, it's going to read for a completely different protein or amino acid, which is going to make a completely different protein. So it's actually going to change all of what the protein's going to do, and it's going to make it completely useless. The thing with this is that it's permanent. So it's going to continue making these proteins, and they're all going to be useless and not going to do anything that they're supposed to do. So basically, to recap for you, we have the DNA over here in the nucleus. This is where transcription happens. So the mRNA takes from the DNA and then leaves the nucleus in the cytoplasm. The cytoplasm is where the magic happens. So the mRNA binds with a ribosome, and then it reads out from codons and anticodons. It reads out through tRNA, dropping off amino acids, making a protein chain. So those are the basis of transcription translation. And then the mutations are we either change a letter and it's read differently, or we completely add or subtract a letter, and that way the protein's made differently as well. So, thanks for listening, guys. I hope you learned something, and yeah.